Five, in 3, 2, 1.
Good afternoon, everyone. My name is Sean Himmel. My dapper-looking friend here is Evan, and together we are...
Wait, that's not right.
Isn't it?
No, I'm Sean.
Then I'm Evan, and today we're going to tell you about how to make a Bristlebot. So a Bristlebot is essentially the head of a toothbrush with a vibration motor and a power source attached, so that when you turn it on, it moves about on its own and sort of skitters randomly about your desk. Cute little creatures, and it's a great activity if you want to introduce kids or anyone who's uninitiated into one of the more simple robotics platforms that you can make. So, in order to make one of these, or many of them, you'll need a toothbrush.
Always good.
A vibration motor. I like using our lily pad coin cell holders with the switch because you can both hold the battery stable and have a nice easy on-off, so you don't have to pop the battery out anytime you want to turn it on or off. And then gobs of hot glue. And the way that I use these, I'll also be using a soldering iron, so don't forget your solder as well. Now the tools involved, like I said, the soldering iron and the hot glue gun. It'll also help to have a set of diagonal cutters. Optionally, you can have some needle nose pliers, extra wire leads, and any craft supplies to make it pretty. I personally like googly eyes. They tend to be really cool. Thanks to my Up in Education for providing those for us.
Those are always fun to put on just about everything.
Anything. Yeah. Googly eyes make everything better. So, without further ado, let's get started making some robots.
Sounds good to me.
All right, so I'm going to go ahead and, well, I've got 2 motors here and I've got 2 battery holders left, so I'm going to take 2 toothbrushes. Now, the ADA recommends that you change your toothbrush out every 4 months or so.
Did you use that one?
Would you like to?
Oh, only if it's seconds.
Now, if they do get a little bit too used, the fraying of the bristles may contribute to a more chaotic movement. The straighter the bristles and the more directional that they go, the better the directionality will tend to be. But this is a chaotic movement, so even if you have the most straight shooting Bristlebot, it's still going to wander around fairly randomly. So I'm going to go ahead and clip some of these heads. Right on.
So Evan, do you have any idea where the idea for these things came from?
Well, around the sort of the mid-2000s, as more cell phones and more pagers kept getting retired, there became an abundance of really cheap, easy-to-get vibration motors. So it became a really popular way to quickly throw together a simple robot to just apply a little bit of power to these motors and fasten them securely to a toothbrush head.
Yeah, I don't know the real history behind them either. I just imagine somebody taking an old pager and just duct taping it to a toothbrush and calling it good.
That's probably not too far off the mark. Now this falls under the beam robotics discipline, which refers to biology. Let's see if I can remember this. The A is aesthetics and the M is mechanics. I forget what the E is stands for.
Biology, electronics, aesthetics, and mechanics.
Thank you, Tony. So basically the idea behind it is extremely simple, almost lifelike systems. Because these things have such a chaotic movement, they can often be thought of as having their own agency, and that's not technically true, but it's fun to sort of just imagine it. It's like that it's going on and conducting its own business and looking for food and trying to find its way about the world. Now really all that's happening is the vibration from the motor is throwing the robot, throwing the whole platform, and the bristles act as almost like a ratchet mechanism to keep it from going back, but to allow it to go forward. Thus results in a net movement in one direction. Now that's not necessarily going to be the case. As you can see, when these things are operational, they tend to go wherever they choose.
Here, I'll get a few of these on.
All right, and
you continue
I'll,
to play. Just because a bunch of these together looks really creepy.
Yeah, and I'm sure that plays on a sort of a human fear of vermin. Seeing all these little skittering things moving out in every direction, it sort of
Oh, that one falls over. That's no good.
invokes the idea of cockroaches or ants or some other heebie-jeebie thing.
And just while you guys are getting set up there, if anybody has any comments or questions, feel free to post them on the YouTube page. We'll be watching.
All right, so these vibe motors that we sell also, have a adhesive back, so those can just stick right on the back of the PCB for the battery board. Then once your soldering iron is up to temperature, now the LilyPad boards are designed to be sewn, but they've got this great metal pad on it that you can also solder to if, say, you're the type that's more comfortable soldering than sewing. Now, I like to give a lot of credit to our e-textiles folks because I found welding is a lot easier than sewing. But this is just a simple procedure. You get both parts, both pieces of metal nice and hot, and melt a little tin onto it, create a nice solid secure connection. All right. So right now I'm just applying a little bit of flux to these joints to get them nice and ready to accept a little bit of solder. So, tin the tip of the iron here, and just a little bit of solder will do. Now, too much solder won't hurt in this case, but if you put too much heat on there, you may risk pulling one of these pads. Now, fortunately, these battery boards have 2 positives and 2 negatives. So if you do end up messing up and pulling a pad on this side, you can just pull your connection and move it over to the other side to try and fix it.
All right. So I've got a bunch of terrible internet jokes about robots here.
I thought you were going to go somewhere completely else with that, but
No.
robots are good.
All right, here we go. Why was the robot angry?
Robots don't experience anger. They're
not-
digital machines.
But the correct answer is because somebody kept pushing his buttons.
Boo.
Oh, they're good. They're good. They're really good.
All right. Just a quick check to see if my my glue gun's up to temperature. Looks all right. So I like to use hot glue. You can use really any adhesive you like. I chose hot glue because it's nice and pliable when it cures. So the vibration. Set it on the table. Yep. All right. So the vibration will be muffled a little bit, but it won't get brittle and just crack off when it's in motion.
Yeah, I have to say that toothbrush head there looks a little used. This will be interesting.
And this one, yeah, this will probably give us a more sort of a lateral movement. We'll see how it goes.
All right, you ready for the next one while that one dries?
Sure.
What is a robot's favorite type of music?
I don't know, heavy metal.
Absolutely. Nicely done.
Now,
That was bad.
Now I'm ashamed.
That you got that one, or the fact that the answer was heavy metal?
Both.
All right.
I'm just gonna make more robots, and they can listen to all the heavy metal they like.
Good.
Have you ever tried to use any other adhesives besides hot glue?
I tried to use an epoxy once. After a little bit, it just cracked apart. The vibration was a little bit too much for it.
What about like a silicone?
I'd imagine a silicone would work. Even like a school glue might be.
So you need something that can move around a little bit. And
Something that has a little, something that when it dries, it has a little bit of flex to it.
Right.
So, I'll let these guys chill there for a minute while they cure. And then pretty much all they'll need now to be technically functional is the battery. But I like to make a little bit of craft to it too. And at this point you can feel free to add any construction paper, googly eyes, or anything you want to make it sort of more than just a toothbrush head with a battery attached.
So we could do 2 little LEDs for each, and then in a dark room it would just be like eyes moving slowly.
that would be fantastically creepy. I like that idea.
There we go. We'll do that to our little swarm in here.
And sure, you could probably, if you wanted to add the resistor in series to the, here it is.
There we go.
If you wanted to add a resistor in series to the LEDs, you could probably attach it to these positive and negative pads. It'd be a fairly straightforward procedure. And I'm taking some of these clipped LED leads that I typically have lying around. I'm just going to get this nice and hot. First,
So I missed it. What do you do with the leads again?
So this is just going to be a little bit of decoration.
Oh, you're giving it a tail?
I'm going to give it antenna.
Nice.
So I'm going to get this nice and hot, as hot as I can. And I use a little bit of solder to allow the heat to transfer a little bit better.
Now, if we had like a microcontroller or something here with some brains, you could use those antennas to like sense where you are or sense a wall.
If you gave it if you set up a contact switch on it, absolutely. These are just going to be rigid, stiff wires coming out of the plastic,
right.
So they're not actually going to connect to anything.
So I've been playing around with the SparkFun Redbot a whole bunch lately, and that's got music wire that used as a contact switch. So you could have something like that where it's some sort of flexible, rigid wire that hits something and creates a contact. So you could, if you sense that you've hit a wall, I guess you can't, can you have direction with these? Can you go backwards, forwards, left, right?
It's a little bit tricky because, well, especially if you're using a used bristle, you're not going to have that fine control, that fine directionality.
Right.
However, there are some manufacturers that actually mass produce these, and they've gotten the dynamic down fairly consistently.
Here, I can put them up to this camera here.
So if you draw attention to the bristles, those you typically find like on the gum massaging toothbrush heads. Those are actually angled back, swept backward, to allow the robot, when it vibrates, to just sort of drift forward. And it's got a fairly aggressive gait. It moves forward and quickly.
So we had a question come in from the audience of, can you use something other than a toothbrush? So does it have to have bristles?
Bristles are preferable. It doesn't have to be a toothbrush. In fact, you could use a dish brush or any other bristly object. Now, as the question asks, does it have to be bristles? Not per se. What you need is some flexible series of columns. So essentially, yes, bristles. But our friend Casey actually posited the idea of if we had a powerful enough motor, we could actually use rebar as the bristles.
That's terrifying.
I like where his head's at, though.
What's the minute? Could you get away with like 3 or 4 touching the ground, or do you need more than that?
Now these have what, about 10 or 12?
Yeah, 12 bristles on this little guy here.
And that's, I suppose, as long as you have a good solid polygon of stability, which that's a concept in basically any vehicle design where the contact with the ground generates a shape that's the polygon, and as long as the center of gravity is over that polygon, then it's a stable shape. So as long as you can establish a firm polygon, 3 is probably a bit light, but if the bristle is stiff enough, you could probably get away with it. I would probably suggest at least 6 if you're designing your bristle head from scratch.
Now, Evan did show me the coolest thing about this robot is it's self-correcting, so I've got it on its back right now. If we turn it on, let's see if it'll do it for us.
Dance, robot, dance. There it goes.
And there it goes. It actually flipped itself over. Come on, get in front of the camera. It flipped itself over. It's self-correcting.
Now these guys are a
roach.
disruptive invasive species. The ones that we're building today aren't as well self-correcting, and so if it gets knocked over, it's sort of stuck there. Now, when you set these prefabricated robots in the environment with them, they'll quickly somehow manage to find every other robot and knock them over.
Oh, we're gonna have to try this as soon as you get those two up.
So this one is now online,
There it goes.
and that guy sort of wanders backwards.
So you're showing these two, and they have different types of bristles. Someone is asking, do metal versus nylon bristles make a difference, or better or worse?
There's no better or worse, it's just different. Since these are chaotic systems, there's really, it really does lend itself to wide experimentation. So if you had, say, like a generic wire brush lying around, that could work as well. It goes back to the whole, it doesn't have to be a toothbrush, it doesn't have to be nylon, it could be metal. Any material that'll give you that kind of flex. And I think I just dropped, there it goes. There it goes. Just glue a motor to the wire brush, yeah. All right. You got that motor, Casey?
You want this junk one?
This one's a little bit frayed.
I don't think it's gonna stay. Yeah, that one will stand by itself.
That
one's
won't.
not. You have to cut that one.
That one won't be. You probably want to watch the cooling off of your lab coat. So yeah, these two are up and in service. So let's set
Here,
these.
let's do them all.
Oh, wait for the last to set up
The killer bot.
the killers. That one was already going. All right, so
They're fighting. Go, 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 go. These two are attacking this one over here.
if you really want, you could probably apply like an X-Acto blade to these guys and make a little Pico Doomba. Oh, these guys are all cowering in the corner here. Let's send someone in to break it up.
There we go. That's awesome.
So that's what I love about the chaotic movement of it. Like, it looks like the two prefabricated robots are going through and attempting to knock over the other ones, and really they're just moving around randomly, bumping into each other, bumping into walls, bouncing off of walls.
I like the one that's just sitting on his back over here.
I've got one doing a nice little pirouette, sitting firmly on its back. Let me get that one back into the frame. Yeah, that one's hopeless. So yeah, these ones aren't completely stable. So any challenge that you might want to attempt if you're going through these. Now this is a fairly simple thing. You can modify it as you like. So my challenge to you is see if you can find a way to mount this so it's more stable when it's in motion. Maybe even self-correcting. That's might be a lofty goal, but I don't know.
So I saw once, the other thing you could possibly do is if you took two of these and put two bristle heads side by side with two different vibe motors, you could sort of get some control maybe?
Absolutely, especially if you have that directionality in your bristles. So if you make sure that you have both sets of bristles aligned the same way and they both have a net direction that they're going to point the machine when it's vibrating.
Right.
You'll definitely get some sort of differential control. It won't be necessarily a clean movement, but it will have some sort of controllability.
So one idea to hack these commercial bristle bots that we have here. So what you're saying is if we added a bridge between them to keep them stable and close together, and we hacked in and controlled one motor at a time, you could potentially steer it, especially since they're forward.
And on the underside, we've got the switch, and we could just replace that with a MOSFET
And just turn them on and off.
Control that with a microcontroller or a transistor, and
take like an AT Tiny or something and just on
absolutely.
And off. Even do some like sensing if you bump a wall. And you can't back up though. That's the only thing.
There's no backing up, but these things, they get committed. So if they attack something and there's an obstacle, they'll just bounce off and pick a different direction.
Yeah.
They're resilient.
So if they are resilient, sometimes unfortunately things fall apart. Do you guys have any recommendations for the viewers as to keeping their parts all together or more tough?
Lots of hot glue.
Enclosure?
Lots of hot glue. You could put an enclosure that does add an extra layer of failability to it, but ways that you can harden it for the environment. You could design your board so that it physically incorporates the vibe motor, the battery, and the switch, so it's one piece. That's pretty close to what we're doing here. Also attaching, maybe finding a different way to attach the bristle, something more resilient than hot glue. I mentioned them before that the epoxies can tend to get a little bit brittle, but if you went overboard with like a potting resin, I'm pretty sure that would never come apart.
I see it not so much running into walls as the problem, because they're not going very fast, but the whole vibration issue tearing them apart. So you need some sort of epoxy or glue that can handle that vibration, or some type of casing. So I believe these aren't using any epoxy. I haven't taken one apart yet. If you have a screwdriver, we could totally take one apart.
This is the machine shop. We have
Let's do a teardown.
Do a teardown.
I require a screwdriver. Phillips, very, very small. We'll go to this camera inside this box here so you can see what I'm doing. There's just a tiny screw in the back of this. I'm assuming you can use this to replace the battery.
No user serviceable parts inside. You'll void the warranty.
Not about. Well, it looks, from what I can tell, it's just the battery right now. So that was what's in the inside, in the butt of this robot. I don't think I can take this thing apart without actually tearing the silicone mold off. But as far as I can tell, if we can see in the inside there is the vibe motor right here, and then the battery sits in the back. I don't want to tear it apart.
Okay.
This toy here. Oh no, he's already got it.
I'm going to town. I'm going in. Cover me.
Evan likes to void warranties right here.
Well, that battery tries to escape. Yep. Soldering out of the way.
All right, while you're destroying that one, Evan, I got another one for you. How many robots does it take to screw in a light bulb?
1. Just program it to do so.
No, but you underestimate robots. 3. 1 to hold the bulb and 2 to turn the ladder.
Okay.
I like that one.
So I've taken off the bristle body here, and that is just part of the mold. So that doesn't actually grant me any further access. And this may appear to have been sonically welded. So yeah, if you, in for a penny, in for a pound. All right.
And you mentioned
You're wearing safety glasses, right?
Yes, these are Z87 approved. Are you?
No.
Safety third.
Safety first, kids.
You mentioned that you don't like epoxy because it fragments and fractures after a while with the vibration motors?
Certain epoxies do.
Certain.
There are definitely some that you can find that have a little bit more give to them. That's the thing about adhesives, is it's an entire zoo of species that you could use to. Oh, that was way easy.
Yeah, it looks like it was just seamed and then glued together. Oh, hold it up to this camera here, because this is our best close-up.
What we have going on here is
I'll hold it. There we go.
much in the same way. We've got your vibe motor and your control board and your battery. Now, as Tony was asking, or as one of our guests was asking about enclosures, this is feels like an ABS, a transparent plastic that is just a two-piece. Case, and for that extra bit of resilience, it looks like it's been sonically welded shut. so you can see a little bit of the trauma that I had on the sides.
How does sonic welding work? I have no clue.
So sonic welding takes two pieces of typically plastic and applies a really high-powered sonic pulse, typically ultrasonic, and that high-powered vibration actually melts the plastic together.
Huh. So you are just melting it.
Exactly, but it's a low-temperature process.
Okay.
It's the vibration and not the temperature that causes the...
I learned something today.
So what you're saying is if you got a motor that vibrated fast enough, you could create one of these as to a sonic welder.
Would it just weld itself? Well, if you used plastic, it would weld it.
If you used a high enough speed of vibration, I suppose theoretically, yes, it could.
I'm assuming we're talking like tens, hundreds of thousands of RPM.
Now the thing is, when you're sonically welding plastic, the two pieces that you're welding together are very firmly fixed. These guys are sort of vibrating loose in the world, so they're not going to build up that disruption of material.
Right.
We got a guest.
All right.
He's here.
So our first guest tonight, this afternoon, is our,
Depending on where you are.
depending on where you are, is our catalog curator, Rob Cowan, who has a fantastic beard and is going to show off his 1 pound.
How you doing, Robert?
Good, you?
Ah, not too bad. We've got a microphone here for you.
I didn't bring a hat.
That's all good. We have a hat. We got a hat.
I'm not wearing.
It completes the beard, I promise.
Everybody's a different.
Oh, we have a chair for you too. Check this out.
Fantastic.
There you go. Let me move my robot out of the way.
I don't think I've ever used a microphone on this.
I know. You want me to hold it for you? No, you're good. All right. Just figured I'd offer. So how's it going?
Good.
Excellent. What have you got for us?
I've got a 1 pound ant weight. Ant weight for the US size class is 1 pound. What for the UK it's like 150 grams or something like that. So this is a US classification ant weight. 1 pound total weight combat robot. This is just meant to turn on and ruin everyone else's lives. So
Tell us a little bit. Do we got a close up? Good. Yeah. So how does it work? Because it looks like there's some sort of drum mechanism here, and then there's wheels up here.
yeah, so that's a drum. So it's a chunk of aluminum. It's like 1.3 inch diameter drum of aluminum, and it has an outrunner motor that is embedded on the inside of this, and it's like a 100-watt outrunner motor, and it spins about 10,000 RPM, and the little screw nubs on there come into contact with things and move them out of the way forcibly.
So which way does it spin? Does it matter? Are you trying to drive it into the ground and chip, or are you trying to knock it? What's going on?
Yeah, so since you're fighting 1 pound versus 1 pound, everyone's the exact same weight as you, right?
Yeah.
So if I'm hitting someone and they're the same weight, and let's say I'm spinning down, they're just going to move against each other. So ideally what you want is the drum to spin like this, so that you're actually flipping up, because then you're actually anchored off of the ground. So you're pushing against the ground and moving them up.
So is the idea to flip, or just kind of knock them against anything else?
I think it's more F equals MA. You want to impart as much force onto them.
Okay.
And so this has a lot of rotational mass, and so if you get that spinning at 10,000 RPM, it's going to come into contact with something that is not spinning at 10,000 RPM and is relatively stationary. One of them has to get out of the way
Right.
quickly.
And hopefully it's not your robot.
Rapid acceleration, rapid deceleration.
So
Right.
we've got a couple of scrap pieces of material. Would you care to give us a demonstration?
Sure. Got some Bristlebots too.
We do. You want to eat some Bristlebots?
It's in a nice little...
I can make more. I've already destroyed one today.
Should we? Yeah, absolutely. While he fires that up, should we pick a sacrificial? Let's have him eat one. That one always falls.
That one almost falls. This one hasn't been a great performance.
Let's do the block of wood.
All right.
Yeah, let's make sure we got some safety glasses.
I used to have full sets over
There's a
there.
hard hat over there.
I've got. Here, if anyone needs some goggles.
Yeah, you guys haven't seen, he knows what's up.
Yeah. Oh no.
So yeah, the way that these guys turn on is they actually use an Allen key. You might be able to see right here. It has a little set screw, and basically,
Hold it up again for the camera.
there you go. So So basically what it has these two little prongs like that, and then it has a screw that comes down in between them. This is from FingerTech Robotics, and when you screw that down, it actually makes contact between the two, and that's the on-off switch. Because the last thing you want is a physical toggle switch that can get interrupted when you're fighting, that can actually get shut off or something like that. So you're actually screwing the contacts in place. So if I screw this in place, there we go, his little nose lights up to indicate that he's on. The other thing to mention is fail-safes. This has a fail-safe that doesn't have communication with the radio, everything turns off. I had to learn that one. So turn on the radio. You guys are really underestimating what this might be like.
No, I'm not.
Okay.
Which way do we want to kick it?
Whichever way physics allows us to.
You want to move? Should we move those? There we go. Oh, we got it moving around.
We good?
Go for it.
That thing makes a lot of noise. Oh dear. Robot down.
What was that you were saying about resilience, Tony? Wow, that shredded. That pulled the contacts clean out.
GoPro, put it on the GoPro.
Ah, GoPro.
There we go. Let's move these out of the way.
I think the rotor is somewhere in the
It
shop.
disappeared that way.
That just cleared.
I hope it survived the fall.
How many RPM did you say?
About 10,000.
All right, that's pretty good. That'll do
Fantastic.
some- So, what are you planning? Are you planning to have a robot on robot? We got a little battle bots.
What?
We're doing a little battle bots here. Is that the plan?
Yes. So at AVC, we are doing both a 1 pound and a 3 pound competition this year, in addition to the ground course. AVC is the autonomous vehicle competition. You guys got the letters up there, right?
Yeah.
No? Okay.
We do now.
So AVC is autonomous vehicle competition. It's where we take, this year it's ground only, unfortunately, because of the FAA and stuff. So we give you a course and we tell you to take a robot, press a button, and make it navigate around that course for prizes and pride, ultimately. That's what AVC is.
Excellent. And then you're also adding battle bots to it as well. Now, is the battle bots open to anybody, or are we keeping it internal?
It is open to. Sorry about that, Greg.
You're just used to standing in front of the camera. That's what it is.
It's open to anyone that has a 1 pound or 3 pounds that adheres to the Spark rules for robotic combat.
And that's up on our site right now.
Correct. It is up on the site if you want to go ahead and check out more information. It's avc.sparkfun.com. Click on 2015 and view the rules, and you can view all the rules for not only the ground competition, but also for the combat robotics as well.
Awesome, thank you. And I've got one more question. Why did the robot go back to school?
Oh, what? That's the question?
Yeah.
Why did he go back to school?
why did the robot
Is it
go-
a riddle? What?
Why not?
Because he needed to get his learn on? I don't know.
His skills were getting a little rusty. This is what I get. This is what you get on the internet for like 30 seconds on the internet.
That is bad.
You're welcome.
That's really bad. Do you want me to open that up, or I can show people?
Yeah, if you want to see what's
Sure,
inside, let's
yeah.
take a look. This is cool. So I noticed the wheels are poking out of the top. Is that just because of the dimension of the wheels, or is that to allow it to drive upside down?
The original design was to allow it to drive upside down, but yeah, it doesn't really work like that so well. It actually can drive by the drum though. So they're just poking up just for space constraints.
Fair enough. And on our rules for the battle bots, if you are flipped upside down, are you out, or is it when you don't drive anymore?
You have to demonstrate motion. Yeah.
Okay.
Demonstrate some sort of motion.
So if you could drive with your little drum, you're still in the game.
Correct. Yeah. So I can flip upside down and actually drive by this drum just fine.
Nice.
This might take a few seconds. So.
It's all good.
But driving by the drum does affect your mechanics when you're attempting to attack. Correct.
All that energy is then transferred into bouncing around on the ground instead.
But motion, that's all you need to show.
Yep.
Now, are we going to have traps on this course, or is it just a field right now, an open field for robot on robot?
Yeah.
Yeah, well, We'll bring in Casey to answer a few questions. This is Casey Coons. He will be mostly in charge of this portion of it.
All right, have Casey sit down, and Sean, you sit down.
All right.
And Robert, you.
While Robert is,
done.
he's almost done.
We'll patiently wait.
There we go.
Oh, yeah.
Yeah. Oh my.
Oh, this is getting interesting.
on TV, guys.
So,
Stand awkwardly behind you.
yeah,
there we
just-
go.
Shall we all pose?
Yeah. Pose for the camera.
Pose.
Perfect.
Robot crew.
Great.
All right.
That's the YouTube shot. That's the cover photo. So
You're welcome.
while we demonstrated a robot on the table with
take it
one
forward.
person wearing safety glasses,
2.
we're going to actually we have a it's about a 5 foot by 5 foot polycarbonate arena. So it'll have a steel floor. And it'll have 1/4 inch thick polycarbonate walls to keep the destruction contained so everybody can come watch. We're hoping to have a few arena hazards. They're still kind of up in the air depending on how far we get. But a match typically lasts about 3 minutes. It's 3 minutes or until one robot stops moving. And the tournament will be double elimination. So if you win, you keep advancing through the brackets. But if you lose once, you go to a loser's bracket where you can continue advancing through. And then
Provided you still have robot left.
yeah, provided there's something to fight with. So yeah, it should be pretty fun and exciting. See some carnage. Hopefully see some robots get roughed up.
Nice.
So, yeah.
Let's take a look in one real quick, and then we'll have Casey come by and show us what he's working on. Yeah. All right, where's our best camera shot here? There you go. You can have that.
So this is the inside. I forgot to introduce everyone. This is Sergeant Cuddles, by the way.
He looks quite cuddly.
He just wants to
You
cuddle.
can tell from the Google's
Oh,
mustache.
yeah, I can. There you go.
Ultimately, he just wants love. So this is what the inside looks like. It's actually pretty simple. We've got a 20 amp ESC right here. This is actually running the Simon K firmware for any of you guys that know what that means. We've got 2 little tiny ESCs in here. That is actually the brand of them, Tiny ESC from Fingertech Robotics. We sell these on the website, so if you're interested. And then these are the Pololu 30 some odd, like 32 millimeter wheels. And then we've got some 50-to-1 motors in here. These are the little micro gear motors from Actobotics that we have. And everything's actually held in place, just press fit with some plastic here. This is just CA glued in place, so they have a little bit of flex. So when it impacts, there's really nothing to snap or break in here. We've got the battery, the power switch, and the transmitter, and that's really about all there is to it. Main drive motor's over there, and the wires just kind of route underneath. This is a raw chassis, so this is what the chassis looks like without anything attached to it. You can see the wire channel down there. And this material is UHMWPE, which is ultra high molecular weight polyethylene. Yes. And the top and bottom is Garolite G10, which is a fiberglass glass composite type of stuff that's really, really durable.
So Robert, that chassis, did you machine that?
Yes, this was machined by myself with a CNC mill. It's kind of interesting to machine. You just need a really sharp tool, but cuts pretty good.
Excellent.
Yeah.
All right, thanks for joining us, and here, your very first kill.
Aw, well, thank you.
Thank you.
Thank you, Robert. All right, let's bring Casey back on to show us what he's been working on since he so gracefully told us about killbots at ADC. Yeah, let's clear out a space for him because we've got.
All right, we're pretty much done with these guys for now.
Yeah, we'll keep the GoPro up here in case we need to show.
Sure, I'll keep a couple of these guys on hand here.
Oh, you've got some screws over here. You got some screws loose, Robert.
Oh, yeah.
I don't get it.
It's okay. One day when you're older, I'll explain it to you.
All right,
I'm older now.
this one's a little heavier, and this one's been through some stuff.
GoPro.
Some stuff.
So anyways,
How do we want to do this?
Well, give it a sec, we'll hold it up. Yeah. So how many pounds is this? This is quite large.
This is a 60-pound BattleBots, and this is actually, so Robert and I are actually headed out to a competition in about, I want to say, a week and a half. So time is precious right now.
Go team.
So this is going to be rebuilt next week, and Robert and I are headed out to a competition called Robo Games, and so we're going to be fighting against people from all over the world. There's people coming from England, Brazil, I want to say France, so people are coming to San Francisco, and we'll be fighting all the way from 150-gram robots all the way up to 220-pound robots. So this is a 60-pounder.
Wait, so you get to fight this against a 125-gram robot?
No.
That would be amazing.
Yeah, there's definitely weight classes. And so this one's for the 60-pound, and this is very, very similar to what Robert has built. Yeah, that was the titanium top plate. Very similar to what Robert's working with. The same style of switch. There's an Allen wrench that actually turns this robot on. In here we have the speed controller for its weapon. So it has a drum just like Sergeant Cuddles. Is that right?
Do you have a name for this one?
So this one is actually Electric Lawn Gnome Supremacy. So silly names are kind of a thing in BattleBots because they have like professional announcers, like wrestling announcers. So it's kind of funny to hear them say these like ridiculous names. So 6 kilowatt brushless motor spins this drum, which is about 18 pounds at almost 15,000 RPMs. So when it gets going, it's pretty nice and loud. And then for drive, using these are 2 Outrunner brushless motors, typically found on very large quadcopters. And then we have a small gear reduction in here that attaches to belts, and the belts are what drive the wheels.
So why belts?
Belts, so with these large robots, the forces are very, very large. And so the idea is that you want some elasticity in your robot to be able to absorb these, rapid accelerations and decelerations. So
you get hit by something going very, very
absolutely.
fast. Right.
So if this was all gear driven, on the first hit, we would probably lose a few teeth, and slowly things just get worse from there. So
belts give you a little bit of play.
Everything is a capacitor.
Yes. So. But yeah, so this is the lightweight. We actually run fuses now because the first time we actually fought this robot, this is how this runs on lithium polymer batteries, and this is how a battery starts. It's nice square, it's nice and battery-like. After our first match, they get nice and puffy, and this was the one that survived. So the other one, the robot actually burned to the ground. So all the controllers fried, all the motors fried, the batteries caught fire. It was just a horrible mess. So we decided to put these little fuses in here to prevent that from happening. So the idea is if a motor controller were to fail, the fuse goes before the batteries.
Like a good fuse should.
Yeah, like a good fuse. The motor controller is essentially the fuse. This is the fire suppression system.
Is the one burning up on YouTube?
Somewhere. If you dig hard enough, if you look up, I think Robo Games, Electric Lawn Gnome, you'll find some great videos. I think we even had a small video out in the back parking lot when we were at the old building, roughing up some parts. This was one of the remnants of that. So this was a part of another robot, and so we ended up hitting it on the axle and breaking the bearing and breaking all this. This is all half-inch polycarbonate. Broke it right off the other robots. So
if I remember in that video, a piece shot almost hit our RV.
Yeah, we're not gonna talk about that.
Yeah. Question from the audience: how many cells are in that battery there that you?
This, what are these ones? This one is a 6-cell. It should be.
22.2 volts,
Yeah.
6 cells.
6 cell. We're running these nice and hot.
5 amp hour.
This 6 kilowatt motor stall current is nearly 250 amps. We've run one up to 275. As soon as it hits 275, the temperature skyrockets and the magnets actually demagnetize. So number of times with our previous motors, we actually hit it's called the Curie temperature, which is the temperature which magnets just break down. And then after that, everything it gets bad. So, but yeah, here's a good example of how things get bad. So that was a motor controller. This was, I don't know if we get good light, but all right, do that. So the motor controller essentially acted as the fuse as the wire melted off of it. So so that's one way to fuse your robots.
I'm guessing those are a little bit more expensive?
Just a little bit. So you can find these on eBay. You can find them on Hobby King. There's all kinds of places. I think Alibaba even sells them. So, but this is the lightweight. This one, hopefully we can get this one back together this weekend, and it's ready to fight. It really just needs. It looks bad, but it's not. I swear.
No, it looks terrifying, is what it looks like.
So we're missing a tooth. So we tore up 3 bolt heads. Right here, and you can see the little remnants of the red Loctite. I even Loctited them.
Red Loctite.
Red Loctite. The great stuff. So I got to replace this tooth. What I'm actually going to do is just weld them on. So that's going to be a little ordeal. If you know anything about metallurgy, it's tool steel, so you have to do kind of special procedures. And then I just need to replace this belt because it's a little chewed up right there. So once I do this, and I think there's one controller that needs a little repair. It's ready to fight again. So
right on.
Excellent.
Now
Yeah.
you mentioned that this is your lightweight. Do you have another robot that's that you're planning on fighting?
So if you want to hold this,
Yeah,
I'll start moving some parts.
Bear with us as we reorganize our space. Need a hand?
All I know is this looks terrifying.
Gotta remember which way it goes.
It's like a puzzle.
All right.
What on earth is this?
I'll sit down for this one. Yeah. So this is going to be a 220-pound BattleBot, and the shell has been removed. It's actually out for heat treat. So I have to have this thing done by this Monday. So yeah, pressure makes diamonds. So anyways, this is it's what we call a full body shell spinner. So there's actually a shell that will sit on top of here, and it'll come down and it looks like a manhole cover. The shell is about 100 pounds, and it has 2 very large teeth. It's made out of hardened steel. That's what's happening right now. It's getting hardened. We've done all the machining and all of the welding that's necessary. So yeah, it's going to sit on this central hub, and this will be powered by 8 brushless motors. So yeah, because we couldn't actually find one big enough that wasn't part of an electric car. So
And those are no-go, or is it too heavy?
too heavy and way more expensive than I wanted to go with. So so the idea is we wanted to use a lot of hobby off-the-shelf parts.
Right.
So the Outrunners, I believe, yeah, here's one right here. So we're using this for the drive. So how many watts are they? So each one of these motors, they're rated for 2,000 watts. I might have a bet on that to see if they actually perform at 2,000 watts. But the idea is that we're going to spin this shell at anywhere between 1,500 and 1,800 RPMs, which should make for quite some sparks. So the shell's 100 pounds. The rest of the robot brings the final weight, according to our models, 218 pounds. But time will tell, and we'll see how it does. So, nice. But this is the work in progress. It's mostly finished. Just got to do a lot of details, and then the wiring is really what the big part is.
Yeah.
So,
are they going to live broadcast? Can we tune in and watch you?
So, if you're interested in following along, there is a website. It's called robogames.net, and I do believe that they might live cast it. If anybody was on Kickstarter, they just recently did a huge Kickstarter, and that's what this is for. Is for the they're going to tape the heavyweights.
Is this is heavyweight?
Yeah.
So we'll be able to see this hopefully.
Yeah.
If not live, then recorded.
Yeah, they're gonna release, I don't know, DVDs or something, direct to DVD. So it's like yeah. So they're gonna televise, or well, not televise. They're gonna record this and release it. It may be live, but check robogames.net. They have, if you're in the San Francisco area, they are actually selling tickets, so you can go. It's at the San Mateo Event Center. So if you can make it, come on in. See Robert and I test our patience and ability to wield a hand to put things back together.
Nice.
So,
hopefully see some sparks fly.
Yeah, hopefully.
Yeah.
On the other guy, not this one.
Yeah, right? No. This is going to win. We're going to root for this. What was this one's name?
This one.
Does it have a name yet?
Yes.
Can we say it on YouTube?
Yes, we'll release the name.
But not
this
right now.
one is called Doomba. So we're gonna paint it like a Roomba because it's gonna sweep the floor. So yeah.
And I have one more question for you.
Yeah.
What do you get when you cross a robot and a tractor?
First thing that came to mind was like tractor pull, but that's not. Please,
what
was it?
No, that'd be so good though. No, a transformer. Wow, there's silence. That's good. That means it was a hit.
Wow.
Awesome. Well, thanks for coming on, Casey, and showing us your robot.
Yeah.
Your robots, multiple, and we'll be rooting for you. We'll be rooting for Doomba.
Doomba. Watch
Excellent.
for it. So.
Thank you.
Thank you.
Thank you.
And for
you guys help clean up.
wonderful
I'm going
host
to...
here, we have another question from the audience.
Yep.
All right.
Does SparkFun have or will they have BattleBot parts for sale?
Ooh, that is a good question. I know that we do have some ESCs, like as Robert has used in his the tiny ESC, and say again? And the drive motors are available. Anything else? That's it. But any other components that one could use on a BattleBot that we have in the catalog?
That's a good question.
Don't we have some RC stuff or no? No.
Servos, people tend to use servos.
Servos, if you want to do a lifting, we have a wide range of Actibotics parts which you could use in your structures.
Really good wire.
Oh, that's nice stuff.
Oh yeah, good stuff.
Yeah.
Feedback.
Give me a hand with this.
Not on mic.
Oh yeah.
Oh, right.
Sorry.
Holy
Here,
cow.
you wanna? Yeah.
Oh, Sean's got it.
I've been working on my deadlift.
Let's get the.
Yeah, this thing is a beast. Nicely done. Thank you.
All right, Sean. Now it looks like you've brought one of yours out.
I don't have a name for it yet, but since we were talking about killbots, this is not a killbot. We're going to move on to just a little project I threw together just because it was fun. I wanted to show that we
stand
could
a chance against these guys.
No. That any of the, even the little like 1 pounder would just destroy this because it's all plastic and rubber and wires. But I'm using an Intel Edison here. I'm going to get a closer up shot. So I'm using an Intel Edison just to drive, and that's going to our Rover 5 platform with both the chassis as well as the main board here, which has H bridges and can take PWM signals in to control the wheels of this. And it's a four-wheel drive, but I'm only driving 2 right now for simplicity. And I have the Edison running Simple CV, which does some super simple vision processing, and it's looking for red blobs like this ball here. And all it's going to try to do is just move towards it. As it sees it in the camera, it chases it around. And then of course dies on me. There it goes. it's just really showing that you can do simple vision processing to add some brains to the robot. As you can tell, the motors are struggling a bit here, and it's a combination of, one, I'm only driving 2 when I should be driving 4, as well as the poor Edison is using a lot of its processing power to look for the red objects, do the vision processing. And what I'd really like to do is offload some of that processing power to something like an Arduino or a microcontroller where it can do PWM or pulse width modulation more effectively, and that way the Edison doesn't have to worry about the driving part and it can just concentrate on doing vision processing. So if you're curious with that kind of stuff, I posted this on my personal GitHub page. It's called Edibot, E-D-I-B-O-T. Take a look at that. Or just take a look at Simple CV, which is a great library that runs in Python, and you can do very simple vision processing, facial recognition, blob tracking, stereoscopic vision, any of those fun things that'll get you up and running very quickly. So that's adding a little bit of brains and not quite on the killing side. All right. Shall we go to the finale? Because we saved the best for last.
So in keeping with the theme of the Bristlebots, and we were talking about the possibility of setting up multiple bristles and alternate configurations, I figured, these guys have been done to death. I mean, it's a fairly common, it's a fairly simple thing. So why not go grandiose when trying it out? So in that mind, I've put together.
Can you give me a hint? Watch, I think that thing's still on. So
All right.
Oh, hold on.
Yep, still plugged in there. All right. I have put together the giant-sized Bristlebot. Now this guy doesn't necessarily have a name yet, but yeah, Steve. Hopefully this will be some kind of dangerous. Now what I've got going on here, instead of your typical toothbrushes, I've got a push broom from a typical shop broom, just the broom head, and we had a table saw that died on us a little bit ago, so I went ahead and harvested the motor from that, and I took a chunk of aluminum, drilled an off-center hole as the vibration weight, so it's an off-centered weight there, and get some cable here. I got it.
You going behind you?
Yep.
Yeah. Mike, can we get like a giant, don't try this at home, safety first, like just blast it across the screen?
Well, I'll go ahead and say it outright. I know what I'm doing.
Mostly.
Mostly. Okay, so I don't know what I'm doing.
He's an expert.
All the more.
I can attest.
All the more, don't try this at home.
1 sec.
All right, well, I'll get this guy plugged in.
There we go. Now we've got don't try this at home. We're good.
Ready?
You should turn his eyes so they're facing. There you go.
The eyes are what makes it really.
Yep, that came right out.
Camera troubles.
Just let me know when you're ready.
How's that microphone treating you, Rob? Do you have any robot jokes? Your favorite robot jokes?
Alright, everybody ready?
All right, now I want you to remember me, not as I was, but as I saw myself. Here we go.
That was awesome.
Yeah.
I built 60 and 200-pound death machines, and that is still terrifying.
There isn't. It's an off-weight giant motor.
You know what you're doing.
Terrifying.
I'm a hack.
Dr. Evan.
All right.
We'll come back to your Sans table. This is very bizarre without a table. I think that was everything. Any last questions, post them. Otherwise, we will get to them as we see them on the comments of the YouTube.
All right.
Thanks for showing it off. That was terrifying.
I'm glad that I could terrify more than just myself with that. So thank you guys for joining us, and thank you all for tuning in. And anyone who's tuning in later down the line, thank you all for watching.
We got one more thing to ask you here. So it's a joke. This one's not a question. Oh yeah, no, this is good. A robot walks into a bar, orders a drink, and lays some cash down on the bar. Bartender says, "Hey, we don't serve robots." And the robot says, "Oh, but someday you will."
Hi.
Thanks for watching.
I got that one.